Okay, this is a look at parabolas in factored form, where we have things that are multiplied. Each of these factors multiplied together would be a quadratic. I think if you think about the FOIL going together, x times x would be x squared times a, so it's going to be y equals a x squared plus, and then there would be some x's, and there would be a constant term r times s. So this is a quadratic, but it's in factored form. It's a set of factors which are multiplied together. The advantage of this form is when things are multiplied together, if any of the factors equals 0, then you know the whole product will be 0. So here's an example of a parabola in factored form. Y equals a x minus 1 times x minus 3. If any of the factors equals 0, the whole product is equal to 0. So if x equals 1, this middle factor is going to be 0. A times 0 times whatever that is going to give us a product of 0. And therefore, when x equals 1, the y coordinate is 0. It's also true that if x equals 3, x minus 3 would be 0. 0 times anything is 0. And therefore, if x equals 3, the y coordinate is going to be 0. Now that helps us in terms of the graph. I'm going to make a quick graph here. If this is 1, 2, 3, when x is equal to 1, when we plug in 1, we get a product of 0, so y equals 0. When x equals 3, we get a product of 0. So the parabola is going to go through 1 and 3. Quick and easy, just looking at the factors and saying when will they equal 0. We also know that the vertex is going to be somewhere halfway between the factors, because it's symmetric, and therefore it's a parabola depending on the shape, depending on what a is. It's a parabola that might open up like this, or it might open down like this, depending on what the shape is. It might be a very wide parabola, or it might be a very steep parabola, but we know it's going to go through 1 and 3. Let me get rid of all that. And now let's look quickly and say, well, let's let a equal 2, and let's let r, the first root, be 1, and the second root be 3. So it's basically what we had before, except we know the shape this time is 2. So if the shape is 2, and r is 1, and s is 3, we're graphing almost the same thing before, except it's now going to be a specific y equals 2 r minus 1, sorry, x minus 1 times x minus 3. I'm going to graph this one in particular. So let's see what we get. So the graph does go through 1 and 3, as we expected, and the vertex is halfway in between. And notice the shape. If we are at the vertex, we go over 1, the shape is 2x squared, we go up 2. So it's exactly the shape we expected, y equals 2x squared, that happens to go through 1 and 3. If we were to change the shape to 3, now at the vertex it's a little steeper, when we go over 1, we go up 3. We could keep playing, obviously. Any shape, 4 over 1 and up 4, it goes through 1 and 3 still, but it's a steeper parabola. So there are lots of parabolas that go through 1 and 3, some opening up, some opening down. They all go through 1 and 3. We're able to see that it goes through 1 and 3 by looking at those factors, and we're able to see the shape by looking at that lead term. So we're actually able to make a very quick graph. Let's take this idea and imagine we have another one, which is let's try y equals negative 1 times x plus 2 times x minus 4. Now if we look at this, we can see very quickly that it's going to go through 4. X equals 4 is going to make this term equal 0, that factor equals 0. This factor is going to equal 0 when x equals negative 2, and it's going to be a parabola that opens down with a shape of negative x squared. So let's see what indeed that looks like. Well, it looks like it goes through x equals 4. It looks like it goes through x equals negative 2. Does it have a shape of negative 1? Well, can we figure out what the vertex is? That's a good point. So halfway between, here's a very rough graph. Here's negative 2, and here's 4. Halfway between negative 2 and 4, add them up. You get 2, and divide by 2, you get 1. So this is the point 1 something. Now, it opens down and has a shape of negative x squared. If you go over 1, you'd go down 1. If we go over from 1 to 4, we're going over a distance of 3. When you go over 3, you typically go down 9 if it's negative x squared. So if this is the point 4, 0, and this is the point 1 something, it's going to be 9 higher. This is the point 1, 9. This is the vertex 1, 9. It goes through those 2 points very quickly. From the shape, we're able to get the y-coordinate of the vertex. Or you could plug in the known x. Halfway between the 2 roots is the average of the roots is the x-coordinate of the vertex, and you could plug that in. But you can also get that from the shape. So I'm assuming that that is the point 1, 9, and this is negative 2, and this is positive 4. Let's see if we can get this to show that any better. We'll expand it out. It definitely goes through negative 2, definitely goes through 4, and there it is up at 1, 9. That's the idea we're going to put into practice. But again, we have the root staring at us. That's when it crosses the x-axis, and this tells us the shape of the curve. All right, we'll be talking about it some more.